and if one of them is negative, you need to find the 2's complement for that particular number and then carry on with the Booth's algorithm, because this again handles the sign bit in this process itself. Now let's begin with the flowchart for this Booth's algorithm. If you have already gone through the previous video, the two numbers we multiplied there were B and Q, but here the numbers are represented by BR and QR because here B and Q are also having their sign bits along. Therefore, to give a different representation, we are using the term BR and QR, which represent that both these numbers are having their sign bits here with them. AC is used here instead of A in the previous video, which is initially 0. Then Qn plus 1 is also a bit, which is again 0, and sequence counter is taken to be equal to the number of bits in the multiplier or multiplicand. Okay, one thing to be noted is that the number of bits in the QR or BR should be basically the larger number of bits. For example, if we have two numbers B and QR and the number of bits in QR are more as compared to BR, the total number of bits in both these numbers need to be equal to the number of bits in the larger number, and the other one can be made equal to that particular number of bits using padding. Okay, now proceeding with the flowchart. Here we have to check the last bit of QR, that is Qn, and Qn plus 1 together. If it is 0, 1, addition is performed between the AC and BR. If it is 1, 0, subtraction is performed. But if it is 0, 0 or 1, 1, arithmetic shift right operation is to be performed. After these two, also arithmetic shift right has to be done for AC and QR. Just make a note of it. In the previous video where the sign bits were handled separately, a normal shift operation, shift right operation was performed. Here it's arithmetic shift right. So there is a difference between the two. Again, the sequence counter is decremented by 1, and as soon as you reach the value 0, you have to stop the procedure. Basically, again, the number of steps need to be equal to the number of bits in the multiplier. So let's begin with an example. We have two numbers, BR, which is 10111, QR 10011. They need to be multiplied. Now, because we need the complement of BR, we've already found here the complement and the 2's complement and kept them ready for the computations. Now, initially AC is 0, QR has this value, and Qn plus 1 is also 0. Now, checking Qn and Qn plus 1, it is 1, 0. That means this. So AC has to be added to the 2's complement of BR, which is 01001. We will add this to AC, 01001, and we will get the result as 01001. Writing QR again. Now, because we have already done this, we need to perform the arithmetic shift right. Let's see how it is done. The first bit is written same. It is copied to the second position, and then 1, 0, 0. This one will go here, 1, 0, 0, 1, and this last one will go here. Just to keep in mind, the first bit is copied to both first and the second position, and then the normal shifting is done. Now you get, after this, because it was 5, after this first step is completed and sequence counter's value is decremented by 1. Now checking again the value of Qn and Qn plus 1. It is double 1. That means a simple arithmetic shift right has to be done, and then this is 0, again 0. Rest is shifted, 0, 1, 0, 0, 1, 1, 0, 0, and 1. After this, another step is completed and it is decremented. So now the value of Qn and Qn plus 1 is 0, 1. That means addition has to be done. The value of BR is to be added to AC. That means 00010 has to be added to 10111, and you will get the result as 011, and DB 01001. Now doing the arithmetic shift right, 1110010 01110, and this 0 will be coming here. You will get 1110010 and 0. After this, another step is completed. Now again checking the value 00, that means a simple arithmetic shift right has to be done. 1 1 Now the number of steps, this was your first, second, third, fourth step completed. That means a last step has to be performed. Now checking the value, that is a 10, that means this, adding the value of 2's complement of BR to this value 0 1 0 0 1, you will get the value 0 0 1 1 0 1 0 1 1 0, and now performing a shift right, you will get 0 0 0 1 1 1 0 1 0 1 and a 1 here. Now this is your fifth step, and as I told you, the number of steps need to be equal to the number of bits in QR. So this is your final answer, which includes your sign bit, right? And the final value of Qn plus 1, that is 1, is the original sign bit of the multiplier, and so it is not considered as a part of the product. This is your final answer that you are getting here. So this was the Booth's algorithm for multiplication. Thank you.